Hey guys, welcome back to Ancient Amnesia Podcast. This is Josh. I'm back with another quick clip show. Today, an article from interestingendeering.com about immortal worms. Can life live forever? According to this new find, Siberian worms buried in the Arctic permafrost for 42,000 years come back to life. This is Pleistocene age worms. This is quite some time. What does this say about life? We actually hear about this also. There are particular insects that can lay dormant for years at a time. There's sea algae that can come back after years and years of being dormant. So this is kind of new research that's leading towards understanding in the cryogenic world, where biology seems to have this mechanism of using cold to contain it and preserve it until a later time when perhaps conditions could be coming back to where they could then exist again. It's saying here, two ancient nematodes from the Pleistocene age are moving and eating normally again for the first time since that age, 42,000 years ago. The roundworms, originally from two areas of Siberia, came back to life in petri dishes, according to a scientific study. Russian scientists from the Institute of Physiochemical and Biological Problems of Soil Science, the Moscow State University, is in now collaboration with the Department of Geosciences, and they defrosted and analyzed some 300 prehistoric worms from different ages and origins. So they had these already in this frozen state, and they began to just kind of defrost them, check them out, find out what they're made of. After being defrosted, the two of the nematodes in the bunch showed signs of life. According to a report, they found that they started moving and eating again. Incredible. 42,000 years, and a worm comes back to life. The researchers were working in the laboratory at the Institute of Physiochemical and Biological Problems in the region of Moscow, where the worms came back to life. The two viable soil nematodes were isolated from the samples of Pleistocene permafrost deposits of the Kolma River lowland. In geology, permafrost is ground, rock, or cryotic soil at or below the freezing point of water, which is 32 degrees Fahrenheit or 0 degrees Celsius, for more than 2 years. Most permafrost is located in and around the Arctic and Antarctic regions. At lower latitudes, alpine permafrost occurs at higher elevations. According to the paper's abstract, scientists have obtained the first data demonstrating the capability of multicellular organisms for long-term cryobiosis in permafrost deposits of the Antarctic. So yeah, this is basically allowing us to say that at even this larger stage of life, we have a mechanism that's allowing a cryogenic state to preserve something for, tens of thousands of years. According to the research paper, one worm came from an ancient squirrel burrow in a permafrost wall of an outcrop in the lower reaches of this river. It is near a Pleistocene park, which is seeking to recreate the Arctic habitat of the extinct woolly mammoth. There's been reports that Russia is planning on using their genetic research labs into recreating woolly mammoths. I'm sure we have heard these stories, for good or worse. The study revealed that the worm is around 32,000 years old. Another worm, which was found in permafrost near the Alzaya River earlier in 2015, is around 41,700 years old. Currently, these two nematodes are the oldest living animals on the planet. So these are now living organisms that stopped moving 42,000 years ago. They are believed to be female, though some nematodes are hermaphrodites. So this is a window towards the successful cryoconservation of species. This is how we would prepare in terms of a cataclysmic event, whether it be a comet, flood, ice age, whatever would come down. We would basically take mating pairs, freeze them, and this could keep them alive for millennia. This discovery suggests that the Pleistocene nematodes have some pretty impressive adaptive mechanisms that may be of scientific and practical relevance for the science-related fields such as cryomedicine, cryobiology, and astrobiology. This also explains on the astrobiology level how life could travel on a comet for tens of thousands and millions of years, impact into a planet that had the conditions for its survival and its development. And that could be a really good understanding of how potentially the Earth got its life. This could signify the start of a new and fascinating scientific conquest toward the survival of multicellular organisms through cryoconservation of endangered species or even human beings themselves. If this works for them, it would work for us. So what does this say about life? In our bodies, our mechanisms built in that we have yet to understand. And science is now finding that this stuff is not just science fiction. We thought this was fun. Again, Interesting Engineering posted the article. Go to their website, check it out. We appreciate you stopping by. Go to ancientamnesia.com for archive articles and information, and we'll see you soon.